Okay, sir. So very good morning to one and all present here. So we are going for the day 4 session 1. So today we have the eminent personality Dr. Samuel sir as the resource person for this first session. So without much delay, let me invite Mr. Rakesh sir for introducing the speaker.
Okay, good morning everyone. It's my great pleasure to introduce once again Dr. G.L. Samuel sir for this section. I have already introduced him in the last one. Okay, let me brief about Dr. G.L. Samuel. He was a professor in the Department of Mechanical Engineering in IIT Madras. He has won several awards and honors. The main of them are Erasmus Mundus European Heritage Scholarship, funded by the European Commission in 2013. He has also won the Brain Korea 21 Scholarship of the Republic of Korea. Then he has won the Best Research Paper Award at the International Conference on Intelligent Flexible Autonomous Manufacturing Systems IFAMS 2000 Coimbatore, India. He has won the National Merit Scholarship Award of the Government of India in 1986. He has also secured second rank in MTech from the Mysore University in 1994. Then he has also presented various book chapters. The book chapter names are Measurement Systems for Characterization of Nano-Finite Surfaces, published by Taylor and Francis Group. Then Laser Micromachining of Semiconductor Materials and Application of Lasers in Manufacturing in 2019 by Springer Publications. He has filed many patents. Some of them are method and setup of wire electric discharge double helix turning in 2019. Then micro and nano texture drill bits with MQL system for low and high aspect ratio drilling of super alloys for sustainability in 2017. He is a reviewer of few books like Tool Design, third edition by Tata McGraw-Hill Publishing Limited, Delhi, and The Machine Drawing, the second edition by Tata McGraw-Hill. He is also a guest editor for International Journal for Precision Technology, special issue on advances in precision and micro manufacturing. He has done several research publications in Indian Journal of Engineering and Material Science, then Precision Engineering, Computer-Aided Design, Assembly Automation, Journal of Engineering Manufacturing, International Journal of Automation and Control, International Journal of Microstructure and Material Properties, International Journal of Machine Tools and Manufacture, then International Journal of Advanced Manufacturing Technology. He is having a visit or collaboration among the various prestigious universities all over the world, like the University of North Carolina, then the Texas A&M University, then key technology partner with the UTS Sydney, Australia, then University of North Carolina during time period 2008 to 11 July 2008 to 21st July 2008. Then he did Watt University, Edinburgh in the year September 2010. University di Milano for the Erasmus Mundus European Union Scholarship, and University di Torino of Italy in June to July 2013. Then he has also collaboration with Chalmers University of Technology in Sweden in the year June 2011. I welcome you, sir, for the section.
Yeah, thank you. So just 1 minute, I'll share the things. So good morning to all of you. Participants can respond. Yeah, good morning to all of you.
So the screen is not shared, sir.
I'm doing it.
Rakesh sir, can you stop sharing?
Yeah. Okay. Now you can see the screen?
Yes, sir.
Where's my video? Yeah. So I'm looking for a response from the participants. Good morning. Yeah, can they unmute? and speak? Saravanan Dika. Can you respond? Are they able to hear me or not? How do you make sure?
We can hear you, sir. Sound
No,
is
you
clear.
can hear, but I want to listen from the participant. Sorry, I'll be. Yeah.
The participant, you can unmute at any time and you can speak.
Yeah, Arun Kumar, can you respond? Bhagya Roy, Soni Kurian, Mohsin, anyone? Yeah, please don't waste time. So whenever I ask, if you respond quickly, we can go forward. Sajid?
Good morning, sir.
Okay, at least one good morning I heard. Thank you. So anyone else? Linto Jose, can you unmute? Jubil? Asked to unmute, but where? Mohsin, are you there on the screen? Niranjan? Yeah, Niranjan. You can hear me?
Yes, sir. Yes, sir.
Okay,
Your
thank you.
voice is clear, sir.
Voice is clear.
Yes, sir.
Okay, so later also I'll be asking questions. So if you respond quickly, that will be better. It will save a lot of time. Okay, so one more time, good morning to all of you. So we'll be today looking at the role of AI in modern manufacturing. So the title given was AI in modern manufacturing. So I said, what is the role actually the artificial intelligence plays in manufacturing? So that's what we are going to look. So the way how I have made my presentation is first we'll be looking at what is manufacturing, then we'll be looking at what is AI, that is artificial intelligence, and then we'll be seeing how this artificial intelligence is applied to manufacturing. So that's what will be the talk today. Okay, so just before I go ahead, how many of you were there in the first lecture? So if I know that, it becomes easy for me. Can someone respond, those who were there in the first seminar?
Almost 60% first phase, sir.
Okay,
Remaining
so
40 only second phase.
okay, I can assume that you know some of these things, what I'm trying to tell and I have told. So I'll be going very quickly. So first thing what we need to understand is manufacturing is a very, very important activity for the economical growth of any country. And these days, so manufacturing stands as the backbone for the economy and the stability of a country. So few years back, it was agriculture and other trades, but now it is basically manufacturing. If any country has advanced manufacturing technologies, so we know that it is a developed country. So that is how the manufacturing is associated with the development of the country. And if you look at the definition of manufacturing, and if you look at what we are today, so both actually doesn't really match. So manufacturing is the word which is actually derived from a Latin word. So it says, which is a combination of words manus and factus. So manus means hand, factus means to make. So meaning of the whole word means manufacturing means making with hand or made by hand. So that was the definition. But today, if you look at the manufacturing, I'm going to show you some of the videos which will bring to you alive the practical scenario in the industry today. So wherein everything is manufactured without the intervention of human hand or without the intervention of human being. So thus manufacturing, though it means something, but the present scenario is entirely different. So we are going to look at what made these kind of a transformation right from just making with hand to the present state of manufacturing what we have. So as all of you know, so manufacturing is the process, is a value addition process where it transforms the raw material into an useful product. So by applying several technologies. So that is what is the definition of manufacturing. Now, if we go back and then look, so we may be feeling thinking that, so we are the one at our present age, we have invented manufacturing, but that is not true. So even the Stone Age people had, no, though they didn't use the term manufacturing or not, but they had the idea of, I can't say metal cutting, but at least the cutting process. So now I'll ask you a question, please respond quickly. Take a blunt knife and then cut anything. So maybe even a fruit, apple, you cut. And then take a sharp knife and then cut. Which will be more easier to cut? Yeah, I'm looking for response from the audience.
Sharp knife, sir.
Yeah, sharp knife, you're right. But why?
It's easy. Since the surface is too thin, it can pierce into the object fastly.
Yeah, how is that? Why? What is the technical this thing? Reason? Can you go into a little more basic?
If we are applying force, then the force is concentrating on a small portion, and it is easy to go through the object.
Okay, go through either cut or any other word for cutting technically? Okay, so we can call it as shearing, or we can also usually in all the most of the process, what happens is you initiate the crack and then the crack propagates and the cut will be formed. So now the basic fundamental thing is that whenever you apply a force, that is what the effort, what we put, then when it is concentrated in a smaller area, so we know stress. Okay, so area plays an important role, force divided by area. So thus when the area, when it becomes smaller, so your effort actually will be converted and then it concentrates on that smaller area. So stress is equal to P by A. Is it right? So thus your concentration when it is there, to cut any material, we need to overcome its shear strength. We need to overcome its shear strength. So thus, when the area is small, so you can reach that point with less effort or with less force. So thus, the sharp knife can cut much faster. So the people who are in the Stone Age, so even they knew about this process and they were using the sharp implements. So they know that when they use the sharp implement, they can actually cut the thing, either it is a meat or a vegetable or anything, they can cut it more easily. So then if you look at some of the countries like China and even in India and other countries, so they had what is called as a bow drill. So where you put a sharp tool and then rotate it. So then you are going to drill through the wood. Then the first lathe which was made was like this. So even Egyptians, they had different types of technologies to cut the stones and then move them up the height. So now to take the stone to that much height, it takes a lot of effort. So thus they had all the technology to do that. So from that period onwards, just give me a second. Yeah. So if you look at the way how they started manufacturing, so when they started making the cars, so they used to design them and then make a wooden model like this, and then over that they put the sheet and then shape it to the required form, and then they assemble it. So this is how they used to design and manufacturing. So that was the older method. Then later in 1970s, so when the computers came, so they started doing the drawing on the computer rather than on the drawing board. So they have transformed. So then they started making the models. So it is not just the drawings, but the models. But initially they were called as the wireframe models. So where it does not define the solid properties, but it can give at least the shape of the products or the components. So we see the 2D drawings are all were like this, but then later, so we had the technology to make the 3D drawings. So you can see the 3D drawings, so which are more easy to understand. See, if you maybe when some of you are teaching engineering drawing to the first years, so you give top view, front view, and side view, and ask them to write the isometric view or ask them to imagine the component or the object what has been drawn. They find it so difficult. But if you can give it in 3D, it's more easy to understand. So then there were problems with realizing it still. So then what has happened is the solid models came, so which will give us the idea, almost like a real object what you see, you can see them on the screen. And then later the analysis came, so where finite element analysis, finite different analysis, difference analysis, and also now you have CFD, so where all the fluids, their flow, we can analyze it. So it is called computational fluid dynamics. So all these things we can analyze. So thus the analysis part was brought into design. So after design, you analyze it, and then we can know whether it will be able to sustain those forces or not, and then you can go ahead. Then on the other side, when you're looking at the manufacturing side of it, so earlier it was all done manually, and the accuracy and quality of the product depends on the person or the operator who was doing that. So thus, if the operator is in a very good mood and is happy, so he will do everything nicely. But in case he's tired or is fatigued, so we find that he will not be able to carry out it efficiently and the quality gets affected. But then later, after 1940s, and then importantly after the Second World War, when people started looking at manufacturing and addressing all the challenges. It looks like during the Second World War, so when the American planes wanted to cross the Pacific Ocean and go to the European side of it, some of the aircrafts crashed. So one reason was actually the fuel was not sufficient. What they did is they tried to increase the amount of fuel, but even then they couldn't cross, because once the initial weight is more, the fuel consumption was higher, so thus adding more fuel was not sufficient. So then they looked at the design of the aircraft, and do you know what will affect the most when a body is moving at high speed? What is the other hindrance? So how can we address this issue? Yeah, can somebody answer? Yeah. Okay, if you are the mechanical engineer at that time, so how do you address this issue? Alfonso, John? Niranjan? Yeah, can somebody answer? Yeah, even if it is wrong, at least if you speak, I'll go forward. Vineet Shah.
Sir, wait.
So how do you reduce weight?
So one way by changing the material, the less denser material.
Yeah, that is true. But at that time, whatever the material they had, it's all aluminum alloys. So they didn't have much technology. Actually, developing materials takes even much longer time. So even today, like companies like GE and Boeing and other companies still work, keep working
Changing
in
the
the
design,
background.
sir. Changing the design.
Yeah. So very good. So what design will change?
The
How
design
do you
which
make it?
reduces
Yeah,
the
you are
weight.
right. Okay. Then, yeah, weight and something more. Yeah.
Yes, sir. Which reduces the forces acting. I mean,
Yeah. How can you reduce the forces acting on them?
making by using some heat treatment methodologies.
No, no. Heat treatment is for structural strength. Yeah. How do you make it more efficient or less resistant to the air?
Yeah, that surface hardening techniques is one way, because on the surface we can improve the strength.
Okay. Yeah, but still something a little more. See now, for example, if you have a car, if it is going at high speed, so what is the basic thing that is resisting that vehicle?
Inertia is the one, sir.
Yeah, that's right. So how do you reduce that inertia? Inertia basically to the wind, no? So the wind will be coming and then it will be resisting it. So that is what we need to reduce. Yeah, how do we do that? Okay, I have a pen. How do you reduce it? Okay, fine. So to save some time, let me go ahead. I have a pen to draw, but it takes just 1 minute to set up, but it's fine. So like if you look at the old automobile, so if you look at the old automobile Jeeps, no, the design will be something like this. Have you seen? So it will be like this. So now when you have the wind, actually it resists. So at high speed, so the wind resistance is the one which actually the primary resistance, and then a lot of fuel is consumed because of that. So if you want to overcome that, we need to design it, that is called as the aerofoil structure. So wherein it is a free-form surface. So nowadays, if you look at the automobiles, so their design will be so smooth like this. So even when the air actually is flowing, so it smoothly flows over it, and thus the resistance will be less. If not zero, but at least it minimizes. Here means it exactly opposes, and then a lot of fuel will be consumed. So same case even with the aircraft. So thus the design of the body of the aircraft need to be changed. So that is called as an aerofoil structure. On the wings also you see, and even on the body you see like this. So the wind actually smoothly goes like this. Sorry for that. So here itself you can see that body structure. So now what I'm trying to tell you is that instead of increasing the fuel, when you are making the design, If you can structurally optimize the design, that is fine, reduce the weight. And the important one is make the shape in such a way that the wind resistance is minimum. So now the challenge, so that is what in engineering drawing, or when you are making the drawing, on one side it is the weight, but on the other side the geometric shape is very, very important. Geometric shape is very important, particularly for these kind of automobiles and any objects which are moving at high speed. So now here the question is very good. So the design, they had some facilities to make a aerofoil structure. Now, next question is, how do you manufacture it? See, usually in turning you would have seen, like if you, so in turning what we do is like the operator will be holding the tool and then he'll be controlling. And if you look at some of your carts in the villages, Kerala, a lot of them are there with a wooden cart. So you see a beautiful shape of the legs, isn't it? So they'll be like this with the shape legs have is a man in the olden days by holding the tool, they make this kind of a shape. That's good. But now, when you want the free-form surfaces, you need to control the machine tool in 3 axis, 4 axis, and 5 axis, minimum 5 axis. So how do you control? So we have one hand. So if you want operator is very skilled, he can control with 2 hands, and then maybe one leg, still he can control. So not more than that. So thus, if you want to maintain the shape, so manual control is impossible. So they need to do something more to address this issue. So that is how John Parson, so from Massachusetts Institute of Technology, so he started thinking and looking at it, and then finally in 1950s they were able to make this kind of a punched tapes, so where they put the holes and then they can control the movement of the machine tool. Does anybody know where this kind of a, that is called NC controlled machine, was used first? Is it in metal cutting or somewhere else? Can someone answer? Yeah. Does it take time to unmute and speak, Shanmugesh?
Sir,
So does it, will it take so much time to unmute and speak for people? Yeah, can someone quickly say at least wrong answer, then we can go ahead. If you are silent, it wastes time. Sudeep? Asked to unmute, okay. Somebody, Rajashekaran? No? Yeah, you're all faculty, I think. Isn't it, Professor Shanmugesh?
yes, sir, yes, sir.
Yeah. So, Gukendran? Not unmute them. Oh, they have some problem with the mic because mic is not shown there. So Vinitsha, I didn't speak. Maybe if you have the list of attendees with their designations and all, that might be much better. Yeah, anyone? Yeah, Alfonso, Johnny. What process? Shanmugesh, other teachers doesn't ask them questions? Other people just they are, or only I am asking questions? Did they answer for other people?
Good morning, sir.
Yeah. Yeah,
This is Dr.
Rajshekar.
Rajasekhar from SRM.
Yeah, good. Yeah. So now by the time I asked all these things, I forgot the question. Can you say what is the question I asked?
When is the first CNC?
Ah, okay. So in which machine it was used? Yeah. Any answer? Okay. Okay, so I'll answer and then go ahead. So it was used in the textile machine, so to make different designs. So the thread, no, they used to manually control. I think even in India, still there are hand looms, so where they control the design of that with the hand control, but they used the CNC machines. Okay, so let me go ahead. So this is how actually they had the punched cards, so on which they'll make the punch and then make the machine to read it and then interpret it and then control the machine tool. So actually I saw it in one of the museum in Sweden. So I think nowadays we don't see, they have almost not there now. So these were the kind of machines. So after that, we see that several types of machine tools have been developed. So with axis controls, even maximum up to 21 axis and more, so they can control. So axis is nothing but it is the freedom for the tool to move. So in one direction, two direction, three directions, or then they have the tilt, rotation about its own axis and all these things. So thus the degrees of freedom for the tool are called as the axis. So thus 5, 6, 8 and even 21. So that is the order. Now we have the freedom to control the tools and the way how the components were manufactured in the old, and now what you can see is they have such a good surface finish that the finish looks something like a mirror finish. Okay, I wanted to ask you a question here, but to avoid delays, let me go ahead. So my question is, how do we get the surface to be like a mirror finish? So what we need to do? Okay, so if you can answer quickly, you can do. Otherwise, I leave the question to you so you can find out the answer. Anybody will volunteer to answer it? How do we get the mirror kind of a finish on a metal? So what we need to do?
Polishing, grinding.
Yeah, that's very good. So we need to polish and grind. Nowadays, actually, we have what is called as a diamond turning. So where they make the mirrors on the metals, so which are being used in the space application. So when they send the mirrors into the space, ordinary mirrors like what we use in our house, they won't work. So if you put them in the sun, after 2 days, the coating will peel off and you cannot use them. So the temperatures in the outer space will be very, very high. Even if we are just outside the earth, not going close to the earth, sorry, sun, but still the temperatures will be like plus 180 or 270, it will reach. And when it is not exposed to the sun, the temperatures will quickly fall to minus 200 at that kind of a range. So thus your ordinary mirrors cannot withstand those temperatures in the space. So we need to use the metallic mirrors. And then to get the light from other objects in the space, so the reflectivity should be something like 99.99%. So to get that kind of a surface finish, coatings will not work because coatings will peel off. Even metallic coatings will peel off. So the metal should be machined in such a way that the surface finish should be nano finish. Then only you'll be able to get these kind of a surfaces. So they are being done nowadays by using what is called as a diamond turning. So diamond tools will be used, and there actually the basic problem is vibration. If there is any vibration in the machine tool, the diamond, which is very hard but brittle, will break. So thus manufacturing these kind of components is not that easy. It is a big challenge, but we are able to overcome that, and we have achieved some of these levels of manufacturing. And also we can see the complicated kind of a shapes. So you can see this one, such a kind of things it is possible nowadays to manufacture. And also the free form kind of a surfaces. So to make these kind of a free forms, so it is very difficult to control the axis. So we need to simultaneously control them to get smooth curves. So they are called as the free form curves. So these kind of shapes are called as the free form shapes. It is a big challenge. And also you can see some of the components, the size and the complexity of the geometry and the intricate shapes, what are there. So this is one of such kind of an example. So which has been used in high precision machining of beryllium, titanium. These are all again hard to machine or difficult to machine kind of materials, but you can see the shapes, how we are able to machine. And also if you look at some of the components, so every time we hear about aircrafts and we travel these days, so if you look at the engine, it is such a complicated kind of design and manufacturing. So even today, this is a big challenge, and much of the research is going on where the reliability expected is 99.999%. So that is the kind of reliability which is seen here, and it's a complicated system, but we are able to realize them. It's all because we have the CNC technology. So thus, from machining, so we moved on to use the automation and other. It's not only in machining. So if you look at an industry, so there are material handling systems, so there are packaging systems, there are control systems and all these things. So then the computers were all actually used in each of them. So ASRS is automated storage and retrieval system. So that is a material handling system. AGV is automated guided vehicles. So thus in assembly, material transport, machining, then CAD, and in even managing the customer relations and dispatch. So everywhere the computers are being used. And then the other development is the robots. Okay, let me ask a question here. What is the meaning of the word robot, or from where it was derived? Does anybody know? Yeah, I'm looking at the response from the participants. If you don't know, you can tell at least you don't know. Okay, Muhammad Abdul Kader. Niranjanan.
I don't know, sir.
Yeah, that's good. At least you answer. Okay. So you're all teachers, so I don't know whether you interact or not. Maybe I am not a good teacher, so I am interacting with you and putting you all in trouble. So even students these days, so they sit and just they want to listen, but that's not the good method of teaching. So interactive teaching is more effective. That's what the researchers in education, they say. So I like to interact. So you're all been escaped, because if it is on a classroom where you're all there, I would have asked you personally, but now you can can hide behind the screens. Okay, fine. Anyway, going ahead, let me show. So the word robot is actually a Czech word, Czechoslovakia. And the meaning of it is a worker or a servant, if not slave, servant. So then they used these kind of a robots. It was initially was used in a novel, so like a fiction kind of a character, but later few years it became reality, and now we see a lot of robots being used in manufacturing, and the way how manufacturing is done is transformed because of the robots. Then in the next stage, so people started looking at what is called as simulation. Okay, so I am again tempted to ask you the question. So what is simulation? So you might have heard these terms, modeling and simulation. So they're all important. So mechanical engineers, yeah, somebody answering, please go ahead.
Sir, is it we are imitating a situation or a process?
Yeah, that is right. So a little more technically to say, so it is nothing but make a model of a particular system, and then you apply the forces and see how it actually responds to the given input. So that is called as a system behavior. So by studying the system behavior is called as the simulation. So for that, obviously, we need a model. So usually there'll be a model, and then so this will be the model of the system. So we have inputs, so how it reacts to that, and then we get the output. So if this is done on the computer system, so that is called as simulation. So simulation is a manipulation of a model for understanding the, okay, it can be simple or complicated, to understand the phenomena, their significance, relations, and interactions in the real system. So we do that on the computer. So one of the example here, what you can see, so this is called as a crash test. So which is one of the important criteria before they get the permission to mass manufacture any of the automobile design. And this used to be a very time consuming and costly process, because so crash test means you need to physically make an automobile. So go and make it to crash against something, and then study the damage which is being caused. And also usually they put actually a dummy here, like a human being, and then they assess what is the damage or injury caused to that person. So when you are sitting on the driver's seat or on a backside or beside the driver, so all these things need to be studied. So that used to be very costly and time consuming process. So if the design is not good, so then again they need to modify the design, manufacture another model according to that, again go and crash, and then do that. It's a very costly and time consuming. But nowadays we have the facility where we can carry out this crash right on the system, that is through modeling and simulation. And we can see what is the stressors, what is the damage which has been caused on this system. And finally, when you are satisfied with this, we can really make a car and then finally test it physically to get the certification, and we can go ahead with manufacturing. So thus it has saved a lot of time and cost. So otherwise, to make each new model of the car, it used to take a lot of time. But nowadays, every fortnight one new design comes. So that is all possible because of simulation. And then there is something called virtual reality. Okay, so I don't want to ask the question. Let me keep going. So virtual reality is not the right term, because virtual means which is not there. Then reality means actually there. So what is not there, you are making it to be there. So that is called as a virtual reality. So that these days, even in manufacturing, you can see So the assembly, you can do it virtually. You don't have to have an instrument. You don't have to have the sub-assemblies. You don't have to have the components, but still we can train the person to make the assemblies in the virtual world. Then it's also being used in the training of the pilots. So we have simulators, so where they create a similar environment like the real cockpit of the flight. And then if the flight is taken up very steeply, so he can actually feel that force and he can feel the uncomfort. So thus he knows when he's driving what is really going to happen and how the passengers will be feeling. So thus he can control and then he can get the training. So these are all can be done by using the virtual reality, and same principles can be applied for manufacturing. And nowadays we have what is called as virtual manufacturing. So wherein the factory is virtual right on the computer. So the components are also virtual and we can make all of them right on the computer. You may ask, what is the use? You don't get the physical products. So what is the use of manufacturing the components? But you can study all their characteristics. You can inspect them and we can actually know the quality of it even before manufacturing. You may ask one more question. So even in CAD drawing, so I'm making something like a cylinder if I want. So I'm designing like this, but then I have another component which has been virtually manufactured. So this is also like this. So what is the difference? You know what is the difference? So on this CAD, if you want to measure the surface finish, you cannot do that. But on this virtually manufactured component, you can measure what is the surface finish, what is the actual dimension which have been achieved. So in the design, we only assign the tolerances, but in the virtually manufactured component, you can actually know what is the size of the component. So thus, virtual manufacturing is a predecessor for actual manufacturing, which saves a lot of time, a lot of efforts and cost. So thus, virtual reality is very much required in these days, where the slogan is do it right for the first time. So it is not trial and error. It's not after making components you say, okay, this is the right method, I'll go ahead. No, everything else you do 9 times on the computer or any number of times, n times. But finally, when you do it, you had to do it right in the first attempt. So then we have what is called the digital manufacturing. So similar to virtual manufacturing, so where everything is done right on the computer. So even if you have an actual factory, so there'll be a digital factory of it, and you can see the production, what is going on in the real factory on your desktop, and that is digitally, you can see them. So these are all the digital manufacturing. So that's virtual reality, 3D environment. So all these things play an important role in it. Okay, now I think I need to ask this question. For all these developments in manufacturing, so what is that invention that contributed most to this machining field? Yeah, you need to answer this. So what is that one invention that helped to bring the manufacturing from that state, so where it was made with hand, to this kind of a fully digital and virtual manufacturing, fully automated manufacturing?
Automation, sir.
Automation, okay. Anything more? Yeah, Hridish, Sridharan. You all might be professors, but I don't see the designation here. Jubil, Zia Joy. So I'm calling you with your names. So if you're faculty, sorry for that. So I don't know. Linto Jose. Yeah. Any other answers?
Sir, is it the usage of computer system to assist in the machining process?
Yeah,
Or
yeah, Alphonse Joy. Thank you for that. So, right answer. So, can you see what is this one? Yeah, what is this?
sir, is it the first electronic computer? I don't know correctly.
Yeah, that's right. That's right. You're right. So it is actually the introduction of the computers is the one which influenced the most. So if computer is not there, you cannot talk about automation. You cannot talk about robots, and you cannot talk about CNC machines, and you cannot talk about CAD, CAM, or CAP, computer aided process planning. So all these things you cannot. So what you see pictured here is the first computer. So which had actually the components which are listed here. So many of them the younger generation would not have seen at all. And the power consumed for one single computer is looks like 160 kilowatts. That means you can even power almost like a town or a city. And the weight of one computer is 30 tons. So you can't carry and all. So that was the way how the computer was. But the computer technology which is developed and made now very powerful, small in size, less in weight, and portable. So that is actually contributed a lot to our mechanical engineering. And finally, now what you are talking about the modern manufacturing. So it's all because of that. So now on one side, we see all these developments. But on the other side, when you look, so what contributed the most to the manufacturing area is the artificial intelligence. Okay, sorry, wherever I kept blank. So that is a place where I wanted to ask the questions. So can somebody say what is artificial intelligence, AI?
Sir, in AI, we force or we use the machines to think and act like human beings. We are trying to incorporate human intelligence into machines.
Yeah, very good and right answer. So it refers to the simulation of human intelligence in machines that are programmed to think like human beings and mimic their actions. So that is the definition. So to put it in simple terms, so like what brain does, if the machine can do that, so that is called as artificial intelligence. So artificial intelligence also includes the capabilities of human being, like what we have, learning, reasoning, and even perception. So you can think and imagine and perceive some of the things which are actually not there, but still you can perceive them. So perception is more than imagination. So it is something higher than imagination. So all these things are possible with the computers. Okay, if you look at the history again, so John McCarthy, so he was called as the father of artificial intelligence. So he coined the term AI, artificial intelligence, in 1956. So I don't know if you have heard this Lisp programming. So we had actually practiced during our days. So Lisp. So then with the help of the computers, only all these technologies, whatever have been proposed, became possible. And Alan Turing is the one who is called as the father of computer science. So who helped actually in all these computer technologies. So right from that time, with the help of the artificial intelligence, so there came lot of applications. So one of the application is the object detection. So where we can actually detect the objects. So though here you see the simple or the general objects, but later they have been applied to manufacturing. So we call this as a machine vision, and where you can recognize the components, objects, you can sort them, you can assemble them. So all these kind of technologies have come, and not only in industry, even in surveillance, crowd control, and in all these things. So people started using these kind of technology. Then nowadays, actually, we also hear about the driverless cars, autopiloted vehicles. So where nowadays, if you have this kind of a car, you don't need to sit on the wheel and then you mean steering and drive and take all the struggles. So you can just enter into the car, relax, and the car is going to take you to the place where you want. So these kind of things are possible with the help of the sensors and the artificial intelligence. So the tasks which are done by human beings, right from simple object recognition to complicated works like driving on the city roads, is being done automatically with the help of artificial intelligence. So even Tesla and all, they have tested. So though there were challenges, there were few accidents, and after that there was some drawbacks. They stopped it and then restarted. So all these things, challenges will always be there, but people have been going ahead with these kind of an intelligence. So nowadays we have the artificial intelligence systems. We can almost interact and then act like the human beings. And not only in industry, but even in the logistics, people started using the artificial intelligence. So wherein to even deliver the products, so maybe even a remote place or in a flooded area or difficult to reach or environmentally hazardous kind of a places, we can use the autonomous vehicles, so drones we call them, and we can deliver the components. So thus both in industrial environment and even in general environment, so we can use them. So thus the artificial intelligence has been used almost in every area, right from automobile, gaming, healthcare, business, finance, government, and also in manufacturing, in which we are interested today. So now, where all this has been used in industry? So in every area, so wherever we have the intelligence of human beings to be used, so in those places, the AI has been used. So wherever there is a repetitive jobs which need to be done, so there we can use the robots. So thus the pick and place robots were one of the first which have been used in the industry. So which are very repetitive and tedious kind of a job. So that has been done nowadays by the robots. So wherever the progressive learning is required, so nowadays with the help of neural networks, so we can make the artificial intelligence systems to learn on experience, and then so AI in all the areas we are able to use it. So why do we need this application of AI? Because there are areas so where with a pure human effort, it is very difficult to handle.